So we're going to write the binomial expansion formula. So if you have a plus b to the power of n, and that can be written as 1 over 0 factorial a to the power of n minus 0 b to the power of 0. So that's the first one, 0, 0, 0. Plus a to the power of n minus 0 is a to the power of n. So you need to bring the n down. So I'm bringing the n down over 1 factorial, 1 factorial, a n minus 1 b to the power of 1. So that's 1 factorial here. And plus, now I need to bring the n minus 1 down to meet n. So you have n into bracket n minus 1 over 2 factorial. And then you get a to the power of n minus 2 b squared. So these are the binomial expansion there. That's the binomial. And these ones here are the coefficients. So that's the coefficient, and that's the coefficient. And the next one will be n minus 1, right? And then you bring the n minus 2 down, n minus 2 over, you can guess what that is now, 3 factorial, you guess right. And a n minus 3 b cubed. So you get plus until you get to n factorial a n minus n b to the power of n over n factorial. And if we simplify this, we get, so we need to remember that 0 factorial equals 1, 1 factorial equals 1, a to the power of 0 equals 1, anything to the power of 0 is 1. So we can write this as a to the power of n plus n, a to the power of n minus 1 b, because b to the power of 1 is b, plus n into bracket n minus 1 over 2 factorial. 2 factorial is 2 times 1, which is 2. You get a n minus 2 b squared. Then you get plus n into bracket n minus 1, n minus 2, and you get a n minus 3 b cubed. This one is over 3 factorial, and it goes on like that. So this one is the first term here, but the coefficient of a to the power of n is 1. The coefficient of a to the power of n minus 1b is n, and this is another coefficient here, so that's a coefficient, 2 factorial. So there's 1 factorial here, and there's 0 factorial there. And this one too is another coefficient. That's 3 factorial. That's the coefficients. So those are coefficients. So we can now write the coefficients now. How do we write coefficients? They are factorials, combinatorial numbers. So we're going to write as n combination 0. This one is n combination 1, and that one is n combination 2, and this is n combination 3. So let's write there. So that will be a to power of n plus a to power of n minus 1 b plus a to power of n minus 2 b squared plus a to power of n minus 3 b cubed plus, now we can see what's the next thing to write. It's going to be n combination 4 plus a to power of n minus 4 b to power of 4, and it goes on. So the n combination can also be written as n colon r colon 0 in this case, a to power of n plus n1 a to power of n minus 1 b plus n2 a to power of n minus 2 b squared plus n3 a to power of n minus 3 b cubed. Why? Because we know that if I put it here, so we know that n colon is written as n combination r, which is n factorial, right, over n minus r factorial r factorial. So that's the formula for that one. So that is the what we call the Pascal coefficient, the Pascal number in a binomial expansion. Those are the coefficient in a binomial expansion. That's the coefficient. That's how you work it out. R starts at 0 for the first term. So this is the first term here. So that's R equals to 0. Second term, first term, second term, third, fourth term. So when you write that, the first binomial expansion formula that you could try and remember maybe is that one. You don't need to memorize it, you just need to understand how it's all put together. It's a bit like cooking. You concord things together. So just remember how that's done together. And again, so you can see that they're the coefficients, and so it's just a to the power of n, b to the power of 0, a to the power of n minus 1, b to the power of 1, and then a to the power of n minus 2, b to the power of 2, a to the power of n minus 3, b to the power of 3, and then the coefficient, you just have 1 n into bracket n minus 1 over 2 factorial. This is 0 factorial, 1 factorial, 3 factorial. So there's a connection there. After writing all that, there's a way to put them together using something called sigma notation, because we're just adding them together. So let's make it fanciful. So this is n, that's the coefficient, right? And that's the coefficient. That is the coefficient. That is the coefficient. Pascal numbers in Pascal triangles. Those are the Pascal numbers in Pascal triangle. First term, second term, r equals to 0, r equals to 1, r equals to 2, r equals to 3. Now, what we can do is to write them in terms of the sigma notation. Can you see what's happening here? If we look at that one, just use this to write the sigma notation. Let's say that is r, right? Because we know it's r. So that's r. R starts at 0. So we can write that as a n minus r, right? Because that's what it is. And b r, right? And then we're adding them all together, right? That's what we're doing. And then And then we put this in front of the numbers because that's what's in front of them. In front of the binomial is the NR. So we put here, let's write in different color. So we put NR. So that's the, and then we say, okay, because we're adding all of them together. So that's a sigma notation. Sigma means addition of all the things together. So that is added to that, it's added to that, it's added to that for the expansion. So we have in sigma notation, and this is written as, so this is sigma notation. Okay, and sometimes you can write it as, the sigma notation can be written as, okay, sigma notation there, and this time we write it as N combination R, because that's what that is, the same thing. And then we write the binomial itself. So this is a binomial expansion, NR minus 1 minus R, BR, right? But the exciting thing is R starts at 0 and all the way to N. So that starts at R equals to 0. So that's R equals to 0 here. R equals to 1. R equals to 2. So we're just adding them together. It's fun, isn't it? Okay, so that's your sigma notation. So let's put this together like that. A plus B to the power of N. And just another way to remember your sigma notation is either to remember that or that. It's the same thing. So that is your sigma notation there. This is your binomial expansion. You can remember it like that, or you can remember it this way. All are the same thing. The coefficients are the Pascal number, Pascal triangle numbers, and that's your binomial expansion formula using the sigma notation and just pure expansion.